All right, welcome back to whitchermath in the COVID-19 virus remote learning and teaching section. Here we are on April 21st, documenting this for history. But anyway, I'm going to teach a very limited and specific skill here, and then we'll give you an assignment, and soon you'll see a video answer key for that assignment. But first, let's talk about solving on this page one-step equations. On the next page, we'll do two-step equations. Okay, first thing you need to remember is what the four basic operations are. We have addition, subtraction, multiplication, and division. Okay, and the inverse, or what undoes those operations. Subtraction undoes addition. Addition undoes subtraction. Division, you get the idea, right? The opposite operation. For example, if I do 3 times 4, remember your fact families from when you were much younger? If I got there by doing multiplication, I can get out of there by doing division. So I can do 12 instead of writing an equal sign. I'm working backwards here. I think that's a better way to show it. We shift the equal sign over and we change the operation. Like if I did 5 plus 7, wow. What is it? Why do I like 12 so much? I added to go this way, and 12 minus 7 equals 5. To get back to where I started, inverse operations. Okay, so we're going to keep that concept in mind about how one operation undoes the other. Inverse ops, we'll call it. Okay, keep in mind I was actually working backwards here, which is a phrase you'll hear and see thrown around often. Work backwards. That's how we check our work. Okay, so in this first example, these are one-step equations. Very simple. If I'm subtracting to get 22, what operation do I need to do to get out of 22 and figure out what x is? I'm adding, I'm subtracting, I need to add. So I'm going to add 6 to both sides. Why both sides? Here's a silly little picture of a scale. One of those pan scales. And think of the center of balance as the equal sign. If I add 6 to one side only, it's going to drop down. It's not an equation anymore. But if I add 6 to both sides, then it stays balanced, okay? So x equals 28 on that one. And then we check it by, basically the check is happening right here. If I substitute the solution for the variable, like all those abbreviations there, so 28 minus 6 equals 22, do the work on both sides, same means true. And on that very simple level, using a problem that you could do in your head, we see solve and check. Sorry it took me a minute to get it all up on the screen there. Let's do the next one without all the visuals here. X, some unknown number, plus 10 equals negative 7. Well, since we're adding, we're going to subtract from both sides. Remember the scale. If I take the same stuff away from both sides, it stays an equation. Sometimes people like to draw a line down here to keep stuff organized, but remember to bring that equal sign down. X equals -17. We want to check it because we were going to substitute the solution for the variable. So we'll start with what we think the solution is, -17, into the original equation. Then you can use your calculator or whatnot if you're allowed to. And what's the same number mean? It means smiley face. That means -17 is the correct solution. Let's do 2 more, and then that will be the end of this short video. Okay, then I'll make a second one showing 2-step equations. Okay, 7x equals 77. That's from up here. I'm just doing these 4 examples. They actually came out of our textbook, but they work for everybody. You don't have to be in this class. Okay, 7 of these things is 77. I'm multiplying, so I need to divide to get out of this. Both sides, hear that language being repeated over and over. 7x cut into 7 equal pieces. Each piece is x. 77 cut into 7 equal pieces makes 11. So we think we've got a solution. We're going to check it, and we're looking for the same number on both sides. Substitute for x in the original equation. And we're crossing our fingers and hoping for, once we complete the work on both sides, we want the same. Same means it's true. And we have room at the bottom for one more, which is going to be, you might hear some family dynamics happening in the background. We're all home here together, so if you hear some noises in the background, that's just what's happening here. Okay? Some number divided by 5 equals 21. So since we're multiplying, wrong. Since we're dividing, we're going to multiply. We're going to multiply both sides by the denominator in this case. Uh-oh, I'm hearing a little argument in the background. Hope that's not getting picked up here. If something divided by 5 is 21, if I multiply by 5, that leaves me with just that one thing. Instead of cut in 5 pieces, it's the whole thing now. And then we multiply over here. You can use distributive property. 20 times 5 is 100, and 1 times 5 is 5. X equals 105. Let's check it. Yeah, I colored it in. Yep, guilty. Back to our original. Substitute what we think the answer is for the x. Complete all original operations. 105 divided by 5 is 21. Checking is getting the number on both sides to hopefully be the same. If it's not the same, what does that mean? If it's not the same, it means there was a mistake in the original solving of the problem. So it means go back and look for mistake and fix. Okay? that was the first video. You can go to the second one, which is going to look kind of the same, but it's going to be a couple of two-step equations. Okay, that's going to do it for now. Thanks for watching, and I'll see you soon.